The function find takes in a vector and returns the locations of all non-zero values in that vector. So it returns the locations or the indices of all non-zero values in that vector. Well, let's start off with Boolean, and it also works for double values as well. So let's start off with vector A equals true, false, true, false. Vector B equals true, true, false, false. Vector C equals 2, 3, 0, 5, 6, 0, 7, 8, 0, 9, 11. Okay? And let's see how the find function works on these. Let's say D equals find A. Well, the question is, where are the non-zero values located in A? That's going to return the indices or the locations, not the non-zero values themselves, but where they are located. And it's interesting as we go forward how helpful this function is. So this is going to give us, there's a non-zero value in indice 1. There's a non-zero value at location or indice 3. So find A, when A is defined as that, is going to give us the vector 1, 3. So D becomes the vector 1, 3. If we did E find B, it's going to give us the vector 1, 2, because those are the indices of the non-zero values in that vector. Keep in mind, true is 1 and false is 0. Now if we come down here, maybe I could fit one more in here. Well, let's not do that. So that's it working on logical vectors. Now let's see it work on numeric vectors. If I do, I think I can fit this one in here. Find, oops, yeah, F equals find C, which is asking where are the non-zero values in C. Well, that's going to give us the vector. Remember the locations. So this is location 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this will give us 1, 2, 4, 5, 7, 8, 10, and 11. Remember, these are the indices. These are the locations of the non-zero values. So you're going to get that as an answer. Okay? All right. So let's see how that can be even more helpful if we use it for Boolean expressions. So erase that, leave the vectors up there. And now I'm going to go vector G equals, and I'm going to do it, the first time I do it, I'm going to do it in 2 stages and then show you how you can do this all at once. Vector G equals C greater than 6. Now, C greater than 6 is going to become the vector. So you're asking, where is C greater than 6? Remember, this is a vector with a logical expression with the scalar here. And so it will apply this scalar, this operation, C greater than 6, to each element in the vector. And so you're going to get the result of 0 or false. In fact, let's do it this way. you're going to get false. When you're doing it in MATLAB, these are going to be zeros. But to clear up some ambiguity, I'm going to put in the words here. You're going to get false, false, because 2 is not greater than 6. 3 is not greater than 6. 0 is not greater than 6. 5 is not greater than 6. 6 is not greater than 6. Let me put these indices here so they don't get lost. 2, 3, 4, 5. Here, 0 is not greater than 6, so that's false as well. Here, 7 is greater than 6, so in slot 7, we get true. 8 is greater than 6, so in slot 8, we get true. 9 is not greater than 6, so there we get false. Sorry. In slot 9, 0 is not greater than 6, so we get false. In slot 10, 9 is greater than 6, so you get true. And in slot 11, 11 is greater than 6, so you get true. Alright, so then you come back, and so you get this vector. If you do G equals C is greater than 6, you get this vector. It also, if you do it in MATLAB, it looks like this. 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. So now if I did a find vector H equals find G, then that's going to give me where in G are there values that are not equal to 0. Well, in slot 7, slot 8, slot 10, and slot 11. Okay? Okay. And that's definitely one way you could do it. You could also just combine and do this in one step, and I think I have enough room to fit it down here. I'll do vector I. I can do it in one step and just say vector I equals find C greater than 6. And if I do vector F, vector I equals find C greater than 6, then I just do it all in one step. C greater than 6 is going to give me this vector here. In MATLAB, it's going to actually be the one with zeros in it. And then find C greater than 6 is going to wind up giving me 7, 8, 10, 11. So I can do it all in one step, right? All right. So that's the power. This idea right here, even more so than just finding the non-zero values in any particular vector. This gets to be very powerful because I can locate in a vector elements that meet a certain condition. So let's do another example here. Let's say vector M equals find where C is equal to 7. Oops. Double equal sign for comparison. Okay, so find C equal to 7. So C is equal to 7 in slot 7. So M is going to be the value 7. If I said N equals find C equal to 9, then the place where C is equal to 9 is in slot 10. So that's going to be the value 10. Let's see, S is find where C is less than or equal to 5, or C is greater than or equal to 9. Okay. So you can do a combo like this. That's going to give you the vector 1, 2, 3, 4, 6, 9, and then 10 and 11. Okay, so this can go on and on and on, and we can do a lot of stuff with this in determining where certain values are in a vector. This is the MATLAB illustration or demonstration of find, the find function. Start off as we did on the board, a couple of vectors. There's vector A. Vector B. Also, let's do vector C. Six, 0, 7, 8, 0, 9. Suppressing output on all of these. Okay, so those are our vectors. Now let's go vector D equals find A. Keep in mind, find returns the index or the location of all non-zero values. So these trues are interpreted as ones, and these falses are interpreted as zeros. So when I do this and execute it, I've already saved the file, so therefore it didn't ask me to save. I wind up with, down here in the command window, D equals the locations 1 and 3, which in vector A, those are the locations of the true values. And so there we go. E equals find, and the same thing for vector B here. Run that, and down here you see E equals 1 and 2, which are the locations of true in vector B. And the falses are zeros, so they don't get located. If I go vector F equals find C, now it's looking for the non-zero numeric values, which is fine. On that, 1, 2, 4, 5, 7, 8, 10, and 11. If you go back up here, locations 1, 2, not that one, 4, 5, not that one, 7, 8, not that one, 10, and 11. And so those are the non-zero locations in vector C. Okay, so now that's fine, but where this gets a little bit more powerful is it works with your logic operators. And so let me do this in 2 steps, as I did on the board. G equals C greater than 6. Okay, so when I run this, it's going to show me all the places in G where all the places in C where the value is greater than 6, where this Boolean statement is true. Okay, so on the first place, so when it compares 2 to 6, it gets 0. And 3 to 6, it gets 0. 0 to 6, it gets 0. It's 5 greater than 6, it gets 0. 6 greater than 6, it gets 0. So the first 5 values, well, is 0 greater than 6, it gets 0. So the first 6 values of G are 0. And so you see that down here where these first 6 values down here are 0. Then 7 is greater than 6, so that's a 1. 8 is greater than 6, so that's a 1. So you've got 1, then 1 here. And then 0 is not greater than 6, so that's a 0. So that's this 0 here. And then 9 and 11 are greater than 6, and so that's why you have these 1s down here on the end. Okay. Now if I did that and then did a find on that, find the places in G where the value is not equal to 0, then it's going to come back and tell me the indices. And so if you look here, now it tells me that at location 7, 8, 10, and 11 you have no zeros, right? So that's a 2-stage process to tell me the locations in C that are greater than 6. I can do it in 1 step by simply doing vector I equals find where C is greater than 6. Right? And when I do that, in one step, I now have found the places in C that are greater than 6. And that proves to be very helpful as we go forward. Okay. So let's look at this concept a little bit more of these logic operators and finding places where the logical operations are true. Let's do vector M equals find all the places in vector C that are equal to 7. Well, there's only one place in vector C where the value is equal to 7, and that's happens to be in location 7. So when I click that, I get a 7 for M. N equals find places in vector C. The value is equal to 9. That happens to be here, which is indexed in the 10th location, so I'm anticipating the 10, and so N equals 10. Vector O equals find the places in C that are less than or equal to 5. Okay, and so that's locations 1, 2, 3, 4. Not this one, but this one. So that's 6. Not these two, and this one here 9. And so those locations are the ones that are less than or equal to 5. So let's run this. 1, 2, 3, 4, 6, and 9 are the locations where in vector C that are less than or equal to 5. And then I'll do one more. This one is a bit contrived, but gets the point across. Find places in C, find places in C. C is less than or equal to 5, or C is greater than or equal to 9. Okay? And so that's going to give me all the things that were my previous vector, and then also slots 10 and 11 because they're greater than or equal to 9. So when I click that, I get 1, 2, 3, 4, 6, 9, and then 10 and 11. And so this can take on many, many forms and allow you to have a lot of flexibility in finding things in vectors.